In the next example, I want actually to calculate something that goes from negative infinity to infinity. Okay, in other words, I'm going to use the third definition, if you recall. So this will be example 2, and let's evaluate the integral from negative infinity to infinity of 1 over 1 plus x squared dx. And this is, I chose a relatively simple integral, but you know, you have in your homework, you'll have to practice more of that. So let's go ahead and solve this. And first thing, I'll use the definition I just showed you, definition 3. It says that if we go from negative infinity to infinity, I can go from negative infinity to a certain value, and then I go from that value to infinity. So the first decision to make is, what is that mysterious value c that nobody asked me about it, but maybe now you'll see how this works. So we go from negative infinity to somewhere, and then we go from that particular value to infinity. And here's my question to you guys. What value would you choose as the upper boundary of the first integral or the lowest boundary of the second integral? Your question is whether we have a theorem that determines which value to put here. Well, really no. Well, you have the squeeze theorem, but doesn't apply here. All we ask C is to be inside negative infinity to infinity. Really, any number. So what value would you choose here? That is convenient. 0 or 1, and 0 is way more convenient than 1. So I'll go negative infinity to 0 and 0 to infinity. So essentially what we're going to choose here, we're going to choose something that is really convenient. As it turned out, you'll see that it doesn't matter in this case. I could have chosen 1 or 5 for that matter, because you'll see some cancellation here. So let's evaluate. Okay, so now each one is either definition 1 or definition 2 kind of in type 1, right? So instead of negative infinity, we're going to say, well, this will be the limit as t goes to negative infinity of the integral from t to 0 of 1 over 1 plus x squared dx plus the limit, and this time we let t goes to infinity and we integrate from 0 to t of 1 over 1 plus x squared dx. So you can see the rationale behind breaking down the integral from negative infinity to infinity to have a value in between, so we can use the limits. Otherwise it's hard to use a limit when you go both to negative infinity and infinity. So let's see. Each integral by itself is not that difficult to evaluate. What is the antiderivative of 1 over 1 plus x squared? The inverse tangent. Okay, so we are looking at the limit as t goes to infinity, to negative infinity, check it, of the inverse tangent. Let's write it like so, and again evaluate it from t to 0 plus the limit, this time as t goes to positive infinity, of the inverse tangent of x evaluated from 0 to t. Okay, so now we're dealing with limits here. And here's what's going to happen. We're going to have the limit as t goes to negative infinity. We evaluate it, and we have the inverse tangent of 0 minus the inverse tangent of t. I'm sorry, we add this one, the limit as t goes to infinity, and here we have the inverse tangent of t minus the inverse tangent of 0. Okay. So far, so good, guys? Now, we can get rid of the limits here. The inverse tangent of 0 is a fixed value. So it will be the inverse tangent of 0 minus, let's put it this way, minus the inverse tangent of negative infinity plus the inverse tangent of infinity minus the inverse tangent of 0. Well, these two cancel out, plus, remember the interval, the domain of the tangent function. In order for the tangent to be invertible or one-to-one, we restricted the domain of the tangent to what interval? Negative pi over 2 to pi over 2. And the only value where the tangent equals 0 is 0. So the inverse tangent of 0 is 0. But even if it wasn't, then we have the inverse tangent of something minus the inverse tangent of the same thing. So that's why either we cancel it because it's equal 0 or because we subtract like terms. Now, what's need to look at is what is the negative inverse tangent of negative infinity. Again, on the same domain, where do we have where the tangent goes to negative infinity? Well, again, remember, this is the result of the limit. So I should have written the limit as t goes to negative infinity of tangent, inverse tangent of x. So this is not precisely accurate, but where are the vertical asymptote of the tangent? Negative pi over 2 and positive pi over 2. So we have, so the inverse tangent of negative infinity will be negative pi over 2. And then plus, likewise, it will be pi over 2. So the result will be 2 pi over 2 or simply pi. Okay.